Hi everybody, welcome to one more of Mrs. John's lesson. This is for Year 13 Physics, Mechanics, Linear Motion, and we are looking at an easy way to solve problems on banked curves using what we call the tan relationship. Okay, so what I have here is a banked curve and there is an object over here that is going in a circle but on a banked curve. Now the force is acting on this object. Gravity force vertically down, so you show the 90 degrees with the horizontal, and the reaction force which acts at 90 degrees to the surface. Now the reaction force can be resolved into its vertical component, which is Fr cos theta, and that's equal to mg, the weight force or the gravity force. This angle is theta, and that's the same as this angle over here. The angles are the same. And the horizontal component is Fr sine theta, which provides the centripetal force. The reason is because the motion is in a horizontal circle, the force has to be horizontal, and the unbalanced force is the horizontal component of the reaction force that provides your centripetal force. Now, so we know that Fc is actually equal to mv squared over r that we've learned before, but we've also learned from here it is the horizontal component of the reaction force, which is Fr sine theta. And then we also know that Fg, your gravity force, is mg, and that is equal to the vertical component of the reaction force. So that is Fr cos theta. Now, if you divide one by the other, and it's okay, you can do that so long as you do it to both the sides of the equation. Okay, now if we look at that, the m cancels out because they're common, and so does the Fr. So what are we left with? So on this side, we got v squared over rg is equal to, now when you divide sine theta by cos theta, you get tan theta. If you haven't already learned it in maths, you probably will in the next lesson or so. Okay? So if you're asked to calculate the speed with which something goes around on a banked curve in a horizontal circle, you get v squared is rg tan theta. And so v is actually the square root of rg tan theta. So in order to know the speed, you don't even have to find out the value of the reaction force or the support force. You just need to know the radius and the angle of banking, and that's what your speed depends on. Okay, this is in the case where we are not considering friction. I'll make another video to show you what to do when there's a banked curve and there's friction involved as well. So I hope this made sense. Bye for now.